The world just witnessed something truly historic. Not in a lab, not behind closed doors, but out in the open, right on the city streets. Beijing has officially hosted the world's first ever humanoid robot half marathon. And yes, you heard that right. Humanoid robots ran a real 21-kilometer race. While humans have been running for centuries, this was the first time that bipedal humanoid robots joined thousands of people to take on a long-distance challenge. And honestly, it might be the most surreal yet fascinating thing we've seen so far in the rise of robotics. Welcome back, guys. Alfie here, bringing you another latest update. Chinese Beijing marathon race against humanoid robots finally happens, and AI Nexus will cover every detail as it unfolds. Let's go. This wasn't just a tech demo or a quirky publicity stunt. It was a full-fledged event with national attention, aired live on Chinese state television. About 12,000 human runners took part in the Beijing Yizhuang Half Marathon. But all eyes were on the small group of humanoid robots trying to keep pace. These machines had to follow the same rules as their human counterparts. No wheels, just legs. They needed to walk or run upright, balance themselves, and deal with terrain shifts like any runner would. It wasn't easy, and it wasn't flawless, but it happened. And that alone is a massive leap forward in robotics. Let's talk about what made this event possible. The race took place in E-Town, short for the Beijing Economic Technological Development Area. If you haven't heard of it, you're not alone. But in robotics circles, it's a major hotspot. The area houses over 100 robotics firms and is supported by a 10 billion yuan government fund specifically aimed at advancing tech like humanoid robots. E-Town has made it clear that it plans to deploy 10,000 robots in the near future, 1,000 of them being humanoids, across industries like manufacturing, healthcare, and public services. So why run a marathon? Because showcasing humanoid capability in the real world is the best way to prove its readiness for real-life applications. And this event checked off that box. The robot competitors had to finish the 21-kilometer course in under 3.5 hours. Some did, some didn't. But the mere fact that they made it this far is a signal to the world, especially to competitors in the US, Europe, and Japan, that China is not playing catch-up anymore. It's sprinting ahead. The route began at the South Square of Nanhaizi Park and wrapped up at the National Information Technology Application Innovation Industrial Park near Tongming Lake. That's a real open public space, not a simulated environment, meaning the robots had to contend with unpredictable terrain, weather, and crowds. Initially scheduled for April 13th, the race was delayed by a week due to strong winds. And that in itself tells you how serious this was. These machines aren't yet wind-resistant, not entirely anyway. We're still in the early innings of this humanoid revolution. Among the competitors, one robot clearly stole the show, Tiangong Ultra. Developed by the Beijing Innovation Center of Humanoid Robotics, this robot not only finished the race, but did it in 2 hours and 40 minutes. That's just 10 to 40 minutes slower than your average human recreational runner. And it's not like Tiang Gong had a smooth ride either. The robot took a tumble at one point due to a low battery, but managed to recover and keep going. That alone speaks volumes about its onboard systems and engineering resilience. Tiang Gong's route was pre-mapped, and it used real-time location tracking to stay on course. It could adjust its direction and speed on its own. No manual inputs required. This was a fully autonomous effort. Its developers equipped it with lightweight but durable leg joints specifically designed to handle the stress of long-distance running. On top of that, it had a built-in heat management system to prevent the motors from overheating. An underrated but crucial piece of the puzzle for any machine doing prolonged physical activity. The robot stood at about 1.2 meters tall and went through 3 battery swaps during the race. Each swap incurred a 10-minute time penalty, but those were built into the rules. A human handler ran alongside just in case it fell again, but for the most part, Tiang Gong handled itself. The victory was more symbolic than financial. Sure, there was a small cash prize, but the real win was global visibility and the massive leap in credibility for humanoid robot capabilities. And Tiangong's win wasn't just about crossing the finish line. It was also a preview. Right after the race, its creators unveiled Tiangong 2.0, a more advanced model with stronger arms, better joints, and a longer battery life. You can bet this new version is being prepared for even tougher challenges, maybe even the upcoming World Humanoid Robot Sport Games in August 2025, which Beijing plans to host. That event will reportedly include robot competitions in track, field, and even football. The age of humanoid athletics is officially beginning. Not every robot had a smooth run, though. Several struggled to finish or faced technical issues. One robot collapsed at the very start of the race, while another crashed into a barrier and needed human assistance. Some failed to complete the full course. Among the more notable disappointments were several G1 humanoids from Unitree, one of China's best-known robotics firms. Unitree was quick to clarify that those specific robots were handled by third-party teams and not by the company itself. According to Unitree, their focus is on preparing for robot combat events rather than endurance racing. Still, it wasn't all stumbles and setbacks. The second-place finisher was the N2 humanoid developed by Beijing-based Noetix Robotics, which completed the race in 3 hours and 37 minutes. Third place went to Shanghai Droid UP's X02, clocking in at 4 hours and 9 minutes. That's over the cutoff time, but still impressive considering the complexity of humanoid motion. One robot that didn't finish but definitely captured hearts was Little Giant, a tiny 76-centimeter robot developed by researchers at Beijing Polytechnic University. It mimicked human gait and arm movement almost perfectly, making it one of the most lifelike participants. Unfortunately, it encountered a technical glitch mid-race and started emitting smoke from its head, forcing it to withdraw. But what it lacked in performance, it made up for in charm. You could argue it was the crowd favorite. Another robot, Quavo, developed by Leju Robot from Shenzhen, had reportedly completed a full 5K in earlier testing without any errors or battery swaps. It didn't finish in time during the actual event, but its performance during trial runs has raised eyebrows. It's probably only a matter of time before Quavo becomes a serious contender too. Now here's where things get even more interesting. The humanoid robot Tiang Gong didn't come out of nowhere. Its developers actually started prepping it months in advance. They collected real-world running data from professional athletes to train the robot's gait, stride strength, cadence, and posture. The goal was to make its running style as close to human as possible. Not just mechanically, but also visually. They even had an early version of the robot participate as a closer during a previous half marathon in November 2024. That earlier version joined the race just 100 meters from the finish line to give people a glimpse of what was coming. And Tiang Gong isn't the only humanoid getting serious about athletics. In a completely separate announcement, P&D Botics, another Beijing-based robotics startup, showcased the improved walking gait of its flagship humanoid, Atom. According to the company, the smoother movement comes from reinforcement learning, a cutting-edge training method also used by giants like Tesla, Figure AI, and Unitree. Essentially, the robot learns to walk better by repeatedly practicing in digital simulations, and that knowledge is then transferred to the physical robot in a process called sim to real, short for simulation to reality. Atom's walking ability is helped by a biomimetic pelvis that mimics how the human hip moves. That design choice makes a huge difference in how naturally the robot moves. If you've seen videos of robots awkwardly waddling, you'll immediately notice the upgrade. This stuff matters, especially if humanoid robots are going to become part of our daily environments, from delivery and customer service to physical labor. Meanwhile, over in Shenzhen, Daimon Robotics just dropped a game-changer in dexterity tech. Their new robotic hand, called DM Hand 1, includes the world's first millimeter-level vision tactile sensor. It's got 40,000 sensing units per square centimeter. That's higher resolution than the human hand. This hand doesn't just grasp objects, it feels them. It can tell the difference between rough and smooth textures, sense slippage, and even determine how much force is needed to hold something without breaking it. and it uses a hybrid control algorithm to match human hand movements in real time. Daimon also showed off a wearable control device that allows a human to remotely operate a robot while simultaneously collecting training data for the robot's AI. That means humans can teach robots new skills just by doing them. And the robots learn directly from observation. So yes, a half marathon with humanoid robots might sound quirky at first, but it's actually a crystal clear signal of where we're headed. Robotics is no longer confined to labs or showrooms. It's stepping into the real world, quite literally, step by step. And if Beijing's robot race is any indication, humanoid robots are going to be running right beside us. Not in some distant future, but within the next few years. Now, you'd think the world couldn't get any crazier with human racing robots. You wouldn't believe what Elon and Tesla Optimus are now setting out to do. A full-on AI robot cage match. For those who've been following the humanoid robotics race closely, Tesla's recent silence on Optimus had been deafening. While competitors like Boston Dynamics and Figure AI were making headlines with flashy demos, Tesla's robotics team had retreated into stealth mode. Now we know why. The newly unveiled walking gait demonstrates a quantum leap in mobility and balance control. According to Optimus engineer Milan Kovac, this breakthrough was achieved through reinforcement learning in simulated environments. The same cutting-edge technique used by today's most advanced robotics firms. The timing of this cage match challenge is anything but coincidental. Elon Musk has always understood the power of spectacle in driving technological adoption. From Cybertruck's armored glass demonstration to SpaceX's daring rocket landings, Musk knows that capturing public imagination accelerates real-world implementation. By suggesting Optimus could compete in physical combat, Tesla isn't just teasing a potential sport. They're demonstrating faith in their robot's durability, reflexes, and real-world adaptability in the most visceral way possible. This idea of robot combat isn't entirely new. The 2014 startup Megabots famously challenged Japan's Suidobashi heavy industry to a giant mech duel in 2017. While the spectacle captured attention, the clunky piloted machines ultimately proved more novelty than revolution. What makes Tesla's proposition different is the autonomous nature of Optimus. We're not talking about remote-controlled machines. These would be AI-driven robots making split-second decisions in unpredictable combat scenarios. The technological implications of robot combat could be profound. Physical competition would push the boundaries of robotic durability, impact absorption, and recovery from falls. The need for instantaneous decision-making under pressure would accelerate advancements in neural network processing. Most importantly, success in such an unpredictable environment would prove a robot's readiness for real-world deployment in factories, construction sites, and other challenging workplaces. Tesla's Gigafactory footage reveals just how far Optimus has come. The once jerky movements have been replaced by smooth, confident strides. The robot now navigates uneven surfaces with human-like balance adjustments. Most impressively, it's already performing useful tasks alongside human workers. A clear sign that Tesla views Optimus as more than just a research project. The potential applications of this technology extend far beyond factory floors. A robot that can withstand the rigors of combat could revolutionize disaster response, handling dangerous environments too risky for humans. The same durability would make it ideal for construction work or mining operations. And the AI systems developed for split-second combat decisions could be adapted for everything from emergency medicine to autonomous vehicles. Of course, the entertainment value shouldn't be underestimated. The success of robot combat leagues like BattleBots proves there's significant public appetite for mechanical mayhem. A humanoid version featuring recognizable robots like Optimus could capture mainstream attention in ways industrial applications never could. This public engagement could be crucial for funding and advancing the technology. The engineering challenges remain formidable. Creating robots that can both dish out and withstand physical punishment requires breakthroughs in materials science, energy storage, and damage control systems. The AI must be capable of making ethical decisions in real time, knowing when to stop a match if a robot is taking too much damage, for instance. And there are serious questions about safety protocols for both the machines and any nearby humans. Tesla's approach to these challenges appears to be twofold. First, they're leveraging their expertise in battery technology and electric motors to create durable, high-performance robotic systems. Second, they're applying their massive AI training infrastructure to develop neural networks capable of handling unpredictable physical interactions. The cage match idea suggests they believe they're close to solving these problems. The competitive landscape is heating up rapidly. Boston Dynamics' Atlas robot has demonstrated remarkable agility and recovery abilities. Figure AI's robots are already working in BMW factories. Agibot is mass-producing humanoids for industrial use. If Tesla can demonstrate Optimus's superiority through physical competition, it could reshape the entire industry's trajectory. Looking ahead, several scenarios seem plausible. We might see organized robot combat leagues emerge within the next few years, serving both as entertainment and as proving grounds for new technologies. Alternatively, the cage match idea could remain a marketing stunt while the real development continues behind factory walls. Either way, Tesla has successfully reignited public interest in Optimus at a crucial moment. The philosophical implications are equally fascinating. As robots become more physically capable and autonomous, we'll need to grapple with questions about machine agency, the ethics of robotic combat, and the boundaries between entertainment and technological progress. What does it mean when we pit AI against AI in physical competition? Are we comfortable watching machines suffer damage for our amusement? From a business perspective, Tesla's move is brilliant. By framing Optimus as a potential competitor in physical challenges, they've created a new metric for judging robotic advancement beyond just industrial utility. They've also positioned themselves at the center of what could become a major new entertainment category. Most importantly, they've demonstrated that Optimus is no longer just a research project. It's becoming a product. The road ahead won't be smooth. Technical hurdles remain in creating robots that can engage in sustained physical competition without constant repairs. Regulatory challenges will emerge as these machines become more capable. And public acceptance isn't guaranteed. Not everyone will be comfortable with the idea of battling robots. One thing is certain, Tesla has thrown down the gauntlet in the humanoid robotics race. Whether the cage match idea becomes reality or remains a provocative thought experiment, it has successfully shifted the conversation. Optimus isn't just coming, it's coming out swinging. The question now is whether the competition will step into the ring or concede defeat before the first bell rings. As we stand on the brink of this new era in robotics, it's worth remembering that today's spectacle could become tomorrow's standard. The same technologies that might power robot combat could also revolutionize dangerous jobs, assist the elderly, and perform tasks we can't yet imagine. Tesla's bold challenge reminds us that technological progress often comes from pushing boundaries, sometimes literally. The world will be watching to see who accepts Optimus's challenge. Will it be Boston Dynamics' parkour-capable Atlas? Agibot's rapidly improving A2? Or perhaps a dark horse competitor we haven't yet seen? Whoever steps up, one thing is certain. The age of advanced humanoid robotics has arrived, and it's bringing plenty of drama with it. What do you think? Is robot combat the future of entertainment and technological demonstration? Or is this just a clever marketing ploy? Would you pay to watch Optimus battle other advanced robots? The conversation about where this technology should go is just beginning, and your voice matters in shaping what comes next. One way or another, the robots are coming, and they're ready to fight. So keep an eye on this space, and so don't forget to subscribe for more latest updates. Thanks for watching, and we'll catch you in the next one.